Hi, in this short video I'll introduce you to Replica.io, an open source project that I started recently. I'll explain what this project is about, its purpose and goals, and how it's gonna develop. With this video, I want to convince you that you should get involved. First, I would like to tell you a bit about myself, so that you know better who is behind the project. I'm Sergey, an independent research engineer. I've got a pretty solid background in software engineering thanks to over 14 years of diverse experience, mostly with system and secure software. Last 7 years I've been focusing on blockchain, distributed and decentralized systems, in particular designing and implementing consensus protocols. I see myself best as someone discovering smart solutions to hard problems and doing this for the common good. In that, I believe in open source, open innovation and collaboration. That is basically why I decided to start this project. By the way, you can contact me using the handle below my avatar on this slide. Now to the project. So what is Replica.io? It's a framework for composing practical distributed replication mechanisms. That's a pretty condensed definition we'll unpack it shortly. But now you may wonder, what does the logo mean? Well, it looks like DNA, which we all know can replicate and recover from damage. The two horizontal strokes also represent equivalence, achieved through communication between the left and the right sides. Finally, it resembles the lambda symbol, referring to functional programming and composability as its core property. The whole purpose of this project is to advance computing by making highly reliable distributed systems more practical to implement. If we think for a moment, we'll realize how much we depend on computing systems nowadays. They also become more and more complex and therefore error-prone. Shouldn't we strive to make those critical systems highly reliable? I think we ought to. Good news: distributed systems can be much more reliable than traditional centralized ones. Bad news: anyone who's tried implementing such fault-tolerant distributed systems knows how hard it is in practice. In practice, we need simplicity and efficiency. Unfortunately, distributed systems are known to be complex and they tend to be less efficient. When reliability is crucial, we can tolerate somewhat decreased efficiency, but we have to do something about complexity. Ideally, we want distributed systems to be as easy to implement as centralized ones. I believe such complex problems can have neat solutions, not only efficient but also easy to use. Clearly, discovering and developing such solutions does take quite some effort, and this project is about making such effort. More specifically, the goal of this project is to develop a well-supported and widely used state-of-the-art framework for building distributed replication mechanisms. This will greatly help to implement highly reliable distributed systems in practice. In this project, we carefully design a collection of primitives, components, tools and guidelines, all for developing core mechanisms of fault-tolerant distributed systems, such as state-machine replication or distributed coordination services. We choose sensible principles to guide the process of designing and implementing generic components, like consensus or various kinds of broadcast. We construct those components out of their protocol logic, more simple components, and primitives like asynchronous communication or local timer abstraction. The most important ingredient, though, is unified means of combination, since they ensure great composability of the elements and make fine modularity possible. Together with built-in capabilities for tracing and controlling execution, this enables effective debugging, validation and analysis of the components we build. Powerful and convenient tools help make best use of those features. Clear guidelines explain everything with simple, easy-to-follow examples. The framework is meant to be generic and independent from any particular target system or use case. For instance, it should be ready to support different flavors of fault tolerance, consistency and synchrony models. Be it strong, weak or eventual consistency under BFT, CFT or hybrid models with strong, partial or no synchrony assumption. There is huge potential for innovation here. We also go beyond the immediate safety guarantees, which ensure that nothing bad happens, and in addition to that, we seriously concern ourselves with rigorous liveness guarantees and memory bounds, so that something useful eventually happens in the system and our nodes don't run out of memory. We keep in mind features highly desired in practice like bootstrapping, reconfiguration, fault detection, recovery of faulty nodes and recovery from a massive system crash. Last but not least, the framework should be just nice to work with. So, how are we gonna develop this project? First of all, radically openly and honestly. No need to hide or disregard anything. Making it understandable and flexible is another important point for smooth integration and wide adoption. We think holistically in that we proactively consider everything of practical importance. For example, how to bootstrap the system or recover it from a massive crash. We want to take advantage of the state of the art, both in research and engineering, as well as to bring innovation back to the field. All done with great care and quality. We start small and grow strong, delivering value regularly and persistently. Now to the roadmap. In the scope of milestone 0.1, we explore the relevant state of the art and come up with clever ideas of how to fulfill project's key technical objectives. This is about the core principles for designing and implementing generic components, as well as built-in capabilities for tracing and controlling execution. For the next milestone, we'll develop those rough ideas into clearly formulated concepts. These will be the core principles that will give us a solid foundation for the whole framework. Next, we get our hands dirty with actual code to see how we can implement those concepts. This is milestone 0.3. By the way, you should expect it to be implemented in Rust. Milestone M1 is about delivering a prototype that clearly demonstrates how the framework will look once fully implemented. All essential features are there, though still pretty rough, but a small selected part is fully implemented, documented and polished up. This would be a good time to start actively attracting broader attention to the project. Next is M2, when we deliver an MVP version of the framework that unlocks some actual, but perhaps not yet industrial, use cases. Think of research prototypes implemented with our framework. At this point, the project should be very well supported and sustainable. The last milestone defined so far, M3, delivers the first release of the framework ready for integration into a real production system. Currently, This project is in early stages and it's being developed entirely in the open from day one. So please don't get confused if there is less to see than you might have expected. Instead, I encourage you to get involved early on. Go and check the GitHub repo, join the Discord chat, follow on Twitter and YouTube. Please ask questions, share ideas, report problems, suggest changes. This project is quite ambitious, so your support is more than welcome. Feel free to contact me directly as well. I would like to conclude my talk with this quote: "To every problem there is a most simple solution. One way or the other, we can solve, whatever that means, any problem. We may think that complex problems need complex solutions, but I believe only simple enough solutions really work." It's not always a good idea to search for the most simple solution, but let's try to find just more simple ones. Thank you.